All right, so this is 2.8b, and notice I changed colors from a blackboard to a whiteboard. I'm sitting here in the sun, and the sun is shining on my blackboard, and I can't read it, so I had to change to a whiteboard, which I'm never going to complain about the sun being out, so we'll just use white. All right, some of you might like the white better, I don't know. Anyway, we're on example 5, and it says to solve this one. And graph the solution set. So notice it says graph the solution set. So it doesn't want it in set builder notation, it wants it graphed. All right, so to isolate the x, what we're going to do, and I did this earlier in a different lesson, and I said, remember, this x is negative, but it doesn't matter where that negative goes. We can leave it up there with the x, or we can move it down here with the 4. So I always try to move it away from the x. If the x is negative, make the other number of the fraction negative so that the x can be positive, so you don't have to deal with a negative x at all. We just have a positive x. So now I have x over negative 4 is greater than 2. Well, how do I get rid of that negative 4? I multiply both sides by negative 4, right? Okay, now notice what I did. In the last example that I gave you negative 3a is less than or equal to 18. And I said if we divide by a negative, we change the sign around. Like that, right? All right, when we multiply by a negative, you also change the sign around. So that greater than becomes a less than. So see what we did? We changed the sign around. So when you divide by a negative or when you multiply by a negative, you change the sign. All right. When you add or subtract negatives, you don't do anything to the sign. But when you multiply or divide by a negative, don't forget to change that sign around. Okay. That crosses out that. Negative 4 times 2 is negative 8. Now it said graph this. It doesn't just want the answer x is negative 8. It wants you to graph it. So let's put a 0, 2, 3, 4, 5, 6, 7, 8. There's negative 8. Can x be negative 8? No, it says that it's less than negative 8. So we have there. And less than is always to the left. And there's our answer. If I wanted to write it in set builder notation, because I like making my parentheses, it would look like this. Okay, so that would be in set builder notation. All right, so hopefully I'm not just plugging away so fast that you're lost. If I am, take your YouTube video and do half time, and it'll slow my voice down. Oh, that would be really painful. Okay, let's look at example 6. We're doing decimals. 2.5x minus 3.48 is less than negative, holy cow, 4.9x plus 2.07. All right, what are we doing? We're solving for our x, but I have x's on both sides. So I need to move the smaller x over with the bigger x. This one here is a negative, so it's a smaller one. So I'm going to move that over to the other side. And I'll take that whole thing. And this is 4.9x. Okay, so I have 2.5 plus 4.9. And that'll give me 7.4x. And I haven't done anything with anything else here, so I'm just going to rewrite the whole thing. All right, so now I'm trying to get my x by itself. So remember, you get rid of the number that's the furthest away. Anything added or subtracted to this x, we get rid of it first. So I'm going to add 3.48 and 3.48, and that gets rid of those. So I have 7.4x is less than 5.55. Okay? Then I divide by 7.4, and I'm not doing anything. I'm not multiplying or dividing by a negative, so I don't have to worry about switching the sign around. So now I have x is less than 5.55 divided by 7.4, which is x is less than 0.75. All right? Now, what did they ask us to do? Solve it. That is the solution to that. If you wanted to, and let me go ahead and write the equation like it was originally. If you want to, because you don't like dealing with decimals, you can take that entire equation or inequality and multiply the whole stinking thing by 100, and your decimals will all go away. Okay, so let me show you something here. We've done this before. We looked to see, oh, this is in the hundreds place, so we're 2 over from the decimal, so we're going to put 2 zeros here, so I know we're going to multiply it by 100. But look, this one only has a 2.5. We're only 1 over, okay? Not a problem. What you do is you look at your inequality or your equation, whichever, if you're going to get rid of the decimals, and you find the number that has the most places to the right of the decimal. This one has 1, this one has 2, this one has 1, and this one has 2. So 2 is the furthest away from the decimal we go. 2 points, 2 decimal points, okay? So you find the one that goes the furthest, and that's how many you multiply it by. You ignore that this one's only 1 and this one's only 1. You look for the one that's the furthest. If I had, for example, 3.487, now I'm 3 away from the decimal, so I multiply the whole thing times 1,000, because all it's going to do is it's just going to make these numbers bigger, and that's okay. All right, so you count how far you are, how many numbers to the right of the decimal place you are, and make that many zeros and multiply the whole thing by that, each one, and that gets rid of all of your decimals, and you can solve it just like normal. Or you can leave it as decimals and solve it that way. That's fine too. And if you look on page 171, example 6, method 2, they did it by getting rid of the decimals. Method 1, they left the decimals in there just like I did, but method 2 showed you how to do it without the decimals. All right, let's jump to example 7. 3 times x minus 4 is greater than or equal to negative 2. Okay? So, nothing weird here. You just do your typical distribution. 3 times x is 3x. 3 times negative 4 is negative 12. Greater than or equal to negative 2. I'm going to add 12 to both sides. And I get 3x. Those go away. Greater than or equal to 10. Because I didn't divide or multiply anything by a negative, I'm still not dividing or multiplying anything by a negative, so my sign does not change. But I did get x is greater than 2/3. All right, so if they want you to write that in set builder notation, not any problem. Okay? But what if they want you to graph it? Graphing it's going to be a little bit more difficult since they are asking you to graph a fraction. All right, so in this case, we have what's called an improper fraction. An improper fraction is a fraction where the top number is bigger than the bottom number. So if we were to say, what is 10 divided by 3, it's somewhere between 3 and 4, right? Because if we were to divide all this out, we'd get 0.33, and we'd just get a number there between 3 and 4. So that's where you graph. Is 3.33, you just kind of make a guess here. You go over 3 and about that far, and it says that x is greater than or equal. So it's solid because it's greater than or equal, and it's bigger. So we just draw our line that way. This is just kind of a guess on where to put it, just so it's whoever's looking at this is like, okay, it's somewhere between 3 and 4, because 3 would be 9 over 3, right? 4 would be 12 over 3, and we got 10 over 3. So we know it's somewhere between 3 and 4. So as long as you show it right here, somewhere between 3 and 4, you're going to be good. Okay, example 8. 2 times 1 minus 3x. You know, as I was making these videos, I keep thinking, man, you guys have got to be so tired of hearing my voice ramble on and on. Just need you to think about something. My wife is in the other room listening to this every single day. And I don't know how she does it, listening to me talk for hours and hours at a time while I make these videos. So, no complaining if you're having a hard time with it, because she has to put up with a lot more. All right, anyway, let's distribute. And we have 2 minus 6x. So remember, 2 times 1 is 2. 2 times 3 is 6. And we take that minus sign with us. Plus 4 is less than 4x minus 14. All right, so we have a 2 and a 4. We can add those together and get 6. Okay. Now, we're going to try to get the x variable. We have 2 of them. We have one there and one there. We're going to try to get the smallest one over with the biggest one. Negative x, or negative 6, is smaller than 4. So we're going to move that over this way. So we're going to add it to both sides. I hope my music isn't too loud for you. I listen to such a variety of music when I make these things. Okay, this is old 70s air supply. Okay, so that goes away. All right, you're like, I'm here to learn math and not listen to you ramble about your music. All right, sorry. Again, we're going to move the smallest number over with the biggest number. So we're trying to get rid of this negative 14 because we're trying to get rid of everything that is with this x. And we get rid of the negative 14 because it's the furthest away from the x. So in order to do that, we add 14 here, add 14 here. So 6 plus 14 is 20. And again, we haven't multiplied or divided by a negative, so our sign doesn't change yet. Now we're going to divide by 10, positive 10, so our sign still doesn't change because we didn't divide by a positive or multiply, or a negative, or multiply a negative. So we end up with 2 is less than x, or another way to write that would be to just put the x in front and let the sign move with it. See, the big end of the x, or the big end is facing the x, so when I turn it around, I have to turn it so the big end is also still facing the x. So that ends up being your answer there. And again, if you're graphing it, you're going to get 0, 1, 2. You're going to get an open circle because it is not equal to 2, but it is greater than 2. And we end up with a graph that looks like that. All right, so I'm sorry, I'm going to have to start on a third video for examples 9 and 10 and then go into some of the problem sets. I have 15 minutes of tape for each video, so that's why I keep stopping about that time. Plus, you need a break. So, next video, example 9.